Let us take this previous JEE Advanced question. It says that let function fx equal to sin pi x upon x square, x greater than 0, and x1 less than x2 less than x3 dot dot up to xn be all the points of local maximum, and y1 less than y2 less than y3 up to yn be all the points of local minimum, local maximum and local minimum of the function. Then which of the option is or are correct? So we need to analyze the local maxima or minima for the function. So we need to of course analyze the derivative of the function. So let us start by analyzing the derivative of the function. So f dash x will be equal to, if I differentiate by u by v rule, it will be x square into pi into cosine pi x minus sine pi x into 2x divided by x to the power 4. So clearly you can see that I can cancel out one x from numerator and denominator because x is positive, x cannot be 0. So it will become pi x into cosine pi x minus 2 into sine pi x divided by x cube. And in the numerator, if you simplify, if I take 2 cosine pi x common, 2 cos pi x common, then it is going to be equal to pi x by 2 minus tan pi x divided by x cube. Okay, so this is the derivative. Now for local maxima and minima, we are going to discuss the sign of this particular expression, that is the derivative. Now here you see that x cube, this particular factor is greater than 0. There is no problem because x is greater than 0. So we need to analyze the sign change of cos pi x and this factor pi x by 2 minus tan pi x. Okay, we need to see that where it is positive, where it is negative. That analysis we have to do. Now cosine pi x graph I have plotted here. This is the graph of cosine pi x. Y equal to cos pi x. So if we level the points, it is going to be, this point will be 1 by 2 corresponding to cos pi by 2. This is correspond to 3 pi by 2. This is 5 pi by 2. This will be 7 pi by 2, 9 pi by 2 and so on. So these are the points where cos x is changing sign. Suppose positive to negative, positive, negative, positive, negative, positive, negative, like that. So these are the point where cos pi x is changing sign. Cos pi x is changing sign, right? And if I analyze pi x by 2 minus tan pi x, where this is changing sign, okay? So for that I have plotted the graph of tan pi x. You can see the graph of tan pi x, which is having x-intercept, which is having, say, the vertical asymptote. This is corresponds to half, and this is corresponding to pi by 2, that is x equal to 1 by 2. Next, this is 3 by 2. Next, it is 5 by 2. These are the vertical asymptotes in the graph of tan pi x. Okay, so this is the graph of tan pi x, and another linear graph pi x by 2. Y equal to pi x by 2, a line with a positive slope passing through origin. That is y equal to pi x by 2. Okay. So the graph of y equal to pi x by 2 and tan pi x, they are intersecting at the points. So these are the points. This is the first intersection. This is the second intersection. This is the third intersection, and so on. They are intersecting at this point. So we have to understand that where this particular factor is changing sign. Where it will change sign? It will change sign when the graph of tan pi x will be above and below this particular line at the neighborhood of a particular point, right? At a particular point to the left and right, the graph of tan pi x will be above and below of the linear graph pi x by 2. So you see that that is happening, where this thing is happening, that is happening at x equal to 1 by 2, because to the left of 1 by 2, tan pi x is above the line, and to the right of pi by 2, tan pi x becomes below the line. So this is one point. Next, this is the point, that is where they are intersecting. That is one point where here to the left of the point tan x is below, to the right tan pi x is above. Next, it will be at 3 by 2. Next, it will be at this intersection. Next, 5 by 2. Next, at this intersection, 7 by 2 at this intersection, 9 by 2 intersection, like that. These are the points where this factor is going to change its sign, because this graph is to the left above and to the right below, or to the left below to the right above, like that. So this first particular factor cos pi x is changing sign at 1 by 2, 3 by 2, 5 by 2, 7 by 2, 9 by 2, this point. And at those points, the second factor is also changing sign, right? 1 by 2, 3 by 2, 5 by 2, 7 by 2. So this factor is changing sign at a set of points, and the other factor is also changing sign at the same set of points. That means when you will multiply the two factor, the product will not change sign at those points, right? One quantity is changing sign from, say, positive to negative. Another quantity is changing sign from negative to positive. Their product is not changing sign. Their product is still negative, right? So this product is not going to change sign in the neighborhood of these points, 1 by 2, 3 by 2, 5 by 2, 7 by 2. That means these are not the point of any local maxima or minima for the function. These are not the point of local maxima or minima of the function. Which are the points of local maxima and minima of the function? That is, these intersection points are the point where this factor is going to change sign, but cos pi x is not going to change sign. So the entire expression is going to change sign. Okay. So now let us analyze that. Suppose what is the sign scheme of the derivative? Let us draw the sign scheme of the derivative, or the wavy curve of the derivative. Okay. Let us draw the wavy curve of the derivative. So if I start with initially before this particular point, you see, before this particular point, what is the sign? Before this particular point, the sign of the derivative will be here. If I start with the starting here tan pi x is above the line. That means this is negative, and cos pi x is positive. So product is negative. So initially the derivative is negative. Then it will change sign here. It will become positive. Next, it will again change sign here. It will become negative. Then again, it will change sign here. It will become positive, right? So the sign is going to change from negative to positive, negative to positive, and so on. The sign is going to change like this. And we know that when the derivative changes sign from positive to negative, at that point for a continuous function, there is a local maxima. When the sign changes from positive to negative, there is a local maxima, and negative to positive means local minima. So we can easily identify this point to be the local minima point. The first one is local minima, second one is local maxima. Then the third one is negative to positive, so local minima, and the fourth one is local maxima. Okay, so in this way, alternately, we will have local minima, local maxima, local minima, local maxima, and so on. So if you now locate the points, so x1, x2, x3, x4, these are the points of local maximum. So that is, you can see that this point will be, this will be x1, this will be x2, this will be x3, these will be the points of local maxima, and the local minima point will be y1, y2, y3. These are the point of local minima. So the very first one, local minima, next one local minima y2, next y3. These are the local minima. Okay, so it will be y1, x1, y2, x2, y3, x3, and so on. If I now come to the analysis, x1 less than y1, is it correct? x1 is to the right of y1, so it is not correct. x1 is more than y1, right? x1 is more than y1 from the graph. Of course, this is the x value that I am writing. This is not the y value. These are the corresponding x value that I am writing, right? These are the x value that I am writing. For this point, what is the x value? For this point, what is the x value? x1. For this point, what is the x value? For this, what is the x value? These are the x value of the point, right? So this point x value must be more than this point x value. So this is not correct. Next is difference between consecutive x, xn plus 1 minus xn is greater than 2 for every n. Okay, so we'll check that one. Now let us see option D. Difference between consecutive xn and yn is more than 1. Can we say that? You see that this distance is y1. This distance is y1. That is the abscissa. And this distance is x1. This distance is x1. Now a simple analysis if we do here, That is, if you take this particular tan value and if you horizontally proceed with this value, then the same value will be achieved at a point which is before x1, right? Because x1, at x1 the corresponding value is more than this value. That means if I take the same height, same functional height and proceed, I will reach a point whose abscissa will be less than this particular abscissa, x1, right? So it is happening something like this. The graph is like this. The graph is like this. Say we are having a value like this and the line is intersecting like this. For the same value, if I repeat here, this will be achieved before the next value, right? So, and what is the period of tan pi x? For tan pi x, the period is, for this function, period will be pi by pi. Pi by pi, that is 1. Period will be 1. That means after an interval of 1 unit, the same value will be repeated. So the higher value will be repeated after an interval of 1. After an interval of 1. That means we can say that the difference between x1 and y1, this abscissa and this abscissa must be more than 1. Okay, so this is actually correct. The absolute difference between consecutive xn and yn is more than 1. Here also the same thing, you see x2 and y3 if you take x2 and y2, the same value will be achieved here which is before x2. So difference between the two abscissa must be more than 1. So option D is correct. Now you see that between x1 and y2, here between these two the difference is more than 1 and between these two the difference is more than 1. That means this between x1 and x2, between x1 and x2, the difference should be more than 2, because between x1 and y2 the difference is more than 1, between y2 and x2 the difference is more than 1. So between x1 and x2 the difference should be more than 2. So this option is also correct. This is also correct. And finally, xn belongs to 2n comma 2n plus half. Let us test that x1. Suppose this is x1. x1 belongs to, see, this particular point is what? This particular point is, this is x equal to 2 and this vertical asymptote is 5 by 2. This is 5 by 2. So x1 lies between 2 and 5 by 2. x2 lies between 4 and 9 by 2. Okay, x1 lies between 2 to 5 by 2. x2 lies between 4 to 9 by 2. So using the pattern we can generalize that xn lies between 2n to 2n plus 1 by 2. Okay, so option C is correct. So B, C, D is correct.